Hello and welcome to the part 2 of the INI Builds A300 Ground School. Moving straight on from the last section, what we're going to cover in today's topic is the FCU, the pedestal, generally sort of the controls around the rest of the flight deck, and if we get time, we're going to move on to the FMS. The FMS may end up being a separate video simply because of how complex it is, just like every other airliner. Terminology wise, I may be getting my terminology slightly confused because an FCU is what they commonly refer to in a modern Airbus type, so I'm trying to keep it more in common with what you may have flown before in the sim, and it's also called a MCP, Mode Control Panel, in a Boeing aircraft. So what is it, why do we care, and where is it? Well, let's take a look now. So we're now looking at the FCU, the Flight Control Unit, and it's more commonly referred to this entire section here. Now, this also includes this subsection on the left, right hand side, and this section here. We're going to cover this all as one topic as the FCU, because generally that's what we're referred to when we talk about these sections here. We said, what is it for and why do we care? Well, first thing to be aware of, if you didn't watch the first episode, to get any numbers on this, you need to have pitch trim, at least one of them, in the on position. Otherwise, the AFS, the auto flight system, will not power up, and subsequently you will have no display. Also, the AFS will power on when you turn the engines on, so if you do forget to turn the pitch trim on and you start the aircraft up, one of the engines up, you will end up getting a display here, but you wouldn't want to depart with the pitch trim in the off position, as that's taking away one of the crucial systems for the aircraft. Now, why do we use this and what is it used for? I'm not here to tell you how to fly an airliner. I'm sure that if you're interested in this product, you already know how to fly an airliner, but let's really briefly go over what it's used for. Airbus like to say it's used for short-term interaction with the AFS, so the auto flight system, or we can just commonly call it the autopilot. So for long-term changes we use the FMS, for short-term changes we use the FCU, and the values here. Well, what's the difference between a long and a short-term change? Well, a good example would be when the controller says turn left heading this, you would need to do that straight away, so we can select the heading and pull and press the buttons that we need to get the aircraft going in that direction, rather than messing around on the FMS. So a long-term change would be, I want you to change the runway or the star or things like this, stuff that's going to affect the aircraft later down the line. You don't fly the aircraft via the FMS because it would be too slow, and also it just wouldn't be very intuitive if you think about it. It makes sense. But that's the distinction that Airbus makes between the two of them. So let's move from the left all the way to the right, even though we're going to, like I said, this whole unit we're going to class as the FCU. PFD, it's pretty obvious, it's just a brightness selector. This one, see we have two brightness knobs, so the inner brightness knob here, as you can see, it's not doing anything, but it is doing something. So the outer brightness knob, you can see there that that's adjusting the brightness of the navigation display, and this one will affect the brightness of the terrain radar or weather radar image that is behind it. Now, a common issue that you can find when you're flying the line are people who leave this knob turned all the way down on the brightness. So effectively you have no weather radar even if you turn it on. So it's just something to be aware of. In the cold knock state, it's left in the on position. Next switch, FD/FPV. What does this mean? Flight director / flight path vector. Bit confusing. Let's talk about it. So I think flight director is fairly understood. You click it up to turn the flight director on, and it's spring loaded back to the center. So in this position the flight director is off, in this position the flight director is on, and in this position we're actually selecting the flight path vector. We will come to the flight path vector when we're in flight, because at the moment you can't view it because the IRSs need to be aligned to view this, which we haven't got at this stage. But it works fairly similar to the one you may have seen in the A320. You can just select it with this selection here, toggling it on, toggling it off. That's basically the way to do it. And in the EFB settings menu, we have a setting to allow that this captain and co-pilot switch to be linked together, so you don't need to manually do it like I did there, turning on both flight directors. You can actually sync them together. Moving on, we've got DH FPA. What does this do? Let's look at DH. This is for setting your decision height. What's a decision height and why would we set it? Well, a decision height is commonly used for a low visibility approach. So if you're doing a normal ILS approach in a nice day, just as we see today in the sim, no need to set a DH. It's normally used for category 2 and category 3 approaches. So you would set the value that you want in the window here, and it will also display it on the bottom right hand corner here of the PFD on the captain and the first officer's side. One thing to note, I know we said we weren't going to talk much about SOPs, but a lot of operators leave it in -5. Now, why do they leave it in -5? If you leave it in -5, then it won't bother you on the display. So when you're on the approach, you would actually start to see it sort of change colour and count down if you had a decision height left in there. And one of the quirks of the A300 is 0 is counted as a decision height. Kind of makes sense because on the category 3 Bravo approaches, you do not have decision height. If you're not sure what I'm talking about here with categories, this episode would go on far too long if I needed to go into that depth right now. Have a quick look up, or if you don't intend to do an auto land, it doesn't matter at all. Basically, what you need to know from this is a lot of operators set it to -5 to get it out of the way, and if you intend to do a low visibility approach, set your minima in this window here. So I'll leave it on -5. FPA. This function is to set the bird's cage on non-precision approaches. At this point in time, this system is not actually operative on the INI Builds A300. We had a little bit of a technical challenge trying to get it implemented. We're going to do our best in the future to make that possible, but once we get to non-precision flying approaches, you will see we actually have a more modern system that we've implemented in the aircraft that A300s were really fitted with that negate this whole system, and this is simply an aid anyway when you're doing a non-precision approach. So this feature actually does not work. This section here, so this sort of sub-panel, to give it its correct name, is the EFIS control panel, which, let me see if I can get this right, I think it's Electronic Flight Instrumentation System, I think. I'm not 100% sure, but you get the idea. It's basically the controls for what we can see on the navigation display and what we can do with it. Now, this is fairly conventional, nothing crazy. If you want to zoom out, you can zoom out and it will zoom out the map setting that we're looking at on the navigation display. Zoom in, zoom out, it works exactly the same way as you'd think on any other plane. What modes do we have? We have plan mode, so let me pop this display out so we can have a look now. Okay, here you can see the display is now shown. Now, we don't have a route in here, so it's not the clearest right now, but obviously when you come to use the aircraft it will make more sense once we have a route and we're aligned and all this sort of stuff. So plan allows us to look through our flight. Plan, hence the name. Key thing to note about this mode is it's orientated north. So you can see north, east, south, west. So it means that whatever we're looking at, it doesn't really care about the direction that you're pointing in. It's always orientated north. Why is this? Pretty good reason, really. Charts are always orientated to the north unless you manage to spin them round on your lap and make them not orientated north, but they are always orientated north. So when you're comparing your flight plan to the chart, it matches. It looks the same on the screen as it does on your chart. That's why they do it like that. Map, it would basically just show you what you've got ahead of you, similar sort of stuff. Arc, it's a fairly similar mode as well. Rows, it works roughly the same way as on the 320 and other aircraft. Where this is used for raw data flying, so raw data ILSs, raw data VOR approaches, all this sort of stuff, and then a test phase, which simply it just shows a test at the bottom, which is partly model at this time. So we're going to review these once we come to the IRS alignment, but this is just a very quick introduction to them now. Okay, we're back and the screen is now popped in. We're going to go through these really quickly and then move on to the rest of it. Constraints, it shows simply the constraints for the SIDS and the stars, or whatever you have in your flight plan. It displays that on the navigation display, the lower screen. Waypoints shows the available waypoints around the aircraft. They are actually limited to a certain value because the A300 can't physically display all the waypoints because of its lack of memory. VORD, what does that mean? VOR DME, so it will display DME stations and VORs, just where they are on the map. NDB, same thing. Airport, will show the airports. It's as simple as that. I'm not going to go over this endlessly. I'm pretty sure you know how this sort of area works. Let's move on. So what have we got here? Speed/Mach. Fairly makes sense. You can just set speeds in here, wind it up, wind it down. Yeah, nothing crazy here. It's just a fairly conventional setup. The only thing to be aware of is this is one of the only ones that you have to set. So we have to set the FCU up. Okay, now what do I mean by this and how does it affect us? So with the A320 series and beyond, so 330, 340, 350, etc., really you don't have to do much on the flight control unit. You simply put your first stop altitude in the window, so the first altitude you expect to level off at, and that's it. The rest is taken care for you, unless you choose to do otherwise. Now, the A300 is more similar to Boeing products, where you do actually need to tell the aircraft, these are the modes I want you to use, and this is what I want you to do. We're going to cover this when we get to the FMS, because at this stage we don't have a flight plan in, so actually most of this functionality here in the middle, it isn't operable until you have a flight plan in. But let's just go over the basic windows of what we have. So speed, like I said, we can put this in just like a 320. We can pull and that selects the speed, and we can push and that will illuminate a light here called preset, but we will come to that at a later stage because we're going to just get a bit lost if we're going over this now. We'll just look at the basic operation. We're just looking at the basic operation of this. Altitude, you can set an altitude in if you want to scroll it from hundreds to thousands. We made it so that you press it, and then now you can wind it up in thousands. If you press it again, you can now do it in hundreds. That's how you do that function. Heading, you can set the heading that you want, and if you push the heading in, it aligns it with where the aircraft is pointing, or where it last knew it was pointing, which is in this case heading 268. Vertical speed, you can set the vertical speed up, you can set the vertical speed down, and to select this you pull like this, so you pull it just like a modern Airbus aircraft. Autopilot, Autopilot 1, Autopilot 2. So the sort of style of the switches on the A300 are a little bit different, and you can see here these autopilot switches look very similar to the pitch, trim and yaw damper. That's because they are fairly same. They are electromagnetically coupled on. Okay, what does that mean? So what it means is if you click them on, they will engage when they need to engage. So you move it and click, it goes up. Now if something causes the system to be like, oh no, I'm not gonna work now, I need to disconnect for whatever reason, they click off. They physically move from the from the on to the off position. They will return to this position, and that's why the electromagnetic coupling let go and it goes and it clicks down. So they're like sort of spring loaded to off, and they get held in on when they're in use, if that makes sense. But all you need to know is this is how you turn them on. And on the ground we can actually turn them on in control wheel steering mode, and it's part of one of the power up tests, but we're not going to go over that today. and you can switch between control steering 1, control wheel steering 2, and do a sort of a test. But let's not dwell on that a little bit too much because that's quite SOP centric. But what is control wheel steering? Let's talk about it now. It's most definitely a term associated with Boeing, but we have it on the A300. It's the only Airbus ever. Obviously, when I say A300, I'm including the A300 and the A310 because they're part of the same family as such. And it's the only Airbuses to ever be fitted with control wheel steering. Now, often referred to in the sim as a yoke, the flight control, it's actually officially called a control wheel. I think it, correct me, even though you can't hear me, whatever, you're going to shout at your screen and say, no, you're wrong, but I believe it comes from nautical terms of the control wheel for the ship. So this is the control wheel steering. Yeah, maybe, doesn't really matter for our purposes. What does it do? So people often describe it as like a poor man's fly-by-wire. I don't think that's really a good description. The best description that I can give you is the autopilot is flying the aeroplane, but you tell it where to go with the control wheel. So if we're in the air and I want to descend, you can push the autopilot, so you push the yoke and it will descend, but it's not you moving the yoke. Sorry, I just called it a yoke. See? Naughty. But you moving the control wheel. So if I push it forward, it moves the control wheel forward, and that tells the autopilot I want to go down. So then the nose comes down, and then if you let go, it will hold it there. So it will hold what you let go. Same with roll and this. Let's not go too deep into this because I'll be honest with you, I don't think anyone ever uses it. I don't think many Boeing pilots regularly use control wheel steering. I believe it's even disappearing off more modern Boeing products, and I don't think anyone would really use it that much in the A300 because it's kind of a halfway house. Either put the autopilot on or put it off. Don't put it in this on-off mode because it's like you're still flying the plane, but the autopilot's flying it for you, but you're flying it. It's kind of like, well, what's the point? I may as well just, if I want to fly it, I'll fly it. If I want the autopilot to fly it, I'll let it fly it. So that's what CWS stands for. CMD, as you can see to the right, stands for command, which is the full-blown autopilot. That is the command. The command is engaged, autopilot's engaged, etc. So that's it basically for the FCU, because everything else is just a mirror of what I had on the first officer's side, but we've already covered that on the captain's side. Like I said, we're going to go through this more once the IRSs are aligned, and we're going to look at what all the buttons do and all the lower row buttons and what we can do and how we can arm them, but this was just a quick overview. Just to tidy it up so we're aware of it now, we're going to talk about it later, we have a hidden click spot for the go levers, which also stand for toga, so select toga for takeoff, and it's this screw head here. So if you're ever wondering where it is, just move your mouse cursor, and then when it changes to this symbol of a pointing finger, that's where it is. And this one here we didn't cover. This is the IES Mach transfer. So when we press it, it changes our speed from knots to Mach. I think every transport category airliner has the same button, so it's nothing crazy. Right, let's move on to the center pedestal, looking down at the instrument displays. Okay, you join me again having a look at the main instrument displays here. So, what have we got in front of us? So we've got our top screen and our bottom screen. I've already been referring to them a little bit before introducing them fully to you, but I'm pretty confident you're aware of the terminology that's used across many different families of aircraft. So, now again, I may be wrong on this point, but I'm pretty sure I'm right. Airbus was the first company to coin, so the first one to come up with the phrase PFD and ND. Because in Boeing worlds, I'm going to try and get this right, it's called an EADI and an EHSI. which I don't know the last time you ever heard someone say, oh, check out the EADI and check out the EHSI. You probably didn't, because it's kind of a bad term. Where do the terms come from? So it comes from the fact that in this period in the 80s, you were effectively converting old analog planes into more modern, streamlined digital aircraft. So an EADI is an electronic ADI. The ADI was the old analog instrument that used to sit in its place. So they just replaced it with a screen, and to try and keep commonality, they just called it an EADI or an EHSI, which is the screen that was on the bottom. So I think Airbus were trying to take a slightly different view of it and said, nah, let's not call it the electronic version of the old analog instrument. Let's name it primary flight display and navigation display. That's what PFD and ND stand for. And to be honest, it's much more intuitive, and I think it shows the fact that I'm pretty sure you wouldn't have heard those phrases, the Boeing phrases, before, or if you have, I don't think you probably regularly call it that. Boeing pilots don't even really call them that anymore, I don't think. But that's their official names back in the day, and this is why we call it a PFD and an ND. So, what is it? What does it do for us? Standard sort of stuff. This is actually a nice phase to be in, to introduce these screens to you where they're not aligned, because they're lacking all their information, so we can sort of talk about, again, this sort of I don't trust screens moment that Airbus had with this plane. Interestingly, so we can see here, 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 and here, you have analog instruments for every sort of indication that you need on the plane. So we have an analog airspeed indicator, we have an analog altimeter, we have this is not analog, this is a digital screen for the TCAS, but was kind of a retrofit afterwards because TCAS became much more important later on in commercial aviation after some mid-air collisions, so that's why that's there. And then we have an analog ADF, so for NDB navigation, and we have the analog VOR here, and they're all here. But we also have the screens in the middle, which also present the same information to us. So on the left side we have the airspeed indication. On the right side we would have the sort of glide, sort of fixed position that we have there. And on the navigation display, obviously you can view VORs, ADFs, whatever else you need. So you can pretty much view whatever you need on here, but you have an analog backup here. So this is something that you kind of get used to. I personally think it looks quite cool because you have both, and you get all the old school charm of analog gauges, but the modern conveniences of a digital screen and a digital display. We're not going to dwell too much on the analog instrumentation because it's simply there mainly as a backup, and that's what it's there for. It's there as a backup, it looks nice, and it all works. These here are the bugs, and they automatically set themselves once you set the speeds in the FMS. You don't have to worry about them. They will automatically set, and they will change to the correct bugs for the approach. If you are on the approach, they will set themselves to the speeds that you've typed into the FMS. So let's take a look at the terrain. It won't display at the moment because we're not aligned, but we'll come to that again in a bit. And that's really it for the introduction to the PFD and the ND. We're going to move across to the center instrument stack. So what are we looking at here? Lots of gauges, a lot going on here, but not quite as bad as it may appear. And this is where I would say the A300 is ahead of its time. I would definitely say it was an aircraft that many have forgotten, many don't even know it existed, but it was actually a real massive pioneer in modern avionics of the way that we think of a plane. Because what we've got going on here, let's not jump the gun, let's go through them bit by bit. So here we have our standby pitch and roll indications, so in case we get a complete failure, we can look across here and we'll know our pitch and our roll, all that sort of stuff. Here are the flap indications. We'll talk more about the flaps when we get to them, but you can see they indicate the slap position and the flap position, and you can see where they're sort of linked there, and they have the limit speeds on there. Not really the easiest place to see, to be honest, the limit speeds. I wish they'd put a big, nice... I know on a lot of Boeings and stuff, they have a big placard, and it says, this is the speed, don't do it. And so these are very easy to miss, or very easy to forget and then do it. But you shouldn't be putting the flaps out too quick anyway, so it's one of those things. This is another... So this is the standby, I guess you could call it the standby altimeter, because you remember I said that this is a backup as such, but kind of not really, because in this period they trusted them more than the screens. This is the actual official standby, so it will just kind of, it's the same sort of gauge. We have an option in the EFB settings menu that allows you to link all of the barometric settings, so if you set QNH on any one of the altimeters, it will set them on all three. Quite a nice option, to be honest, because then you don't have to worry about, did I set them, we're flying this thing single pilot at the moment, so all the help we can get is great. Also, as you can see, moving back to here, this one has pull for standard. If you pull it for standard, it will automatically set standard. And there's an option in the EFB to synchronize these across all of them. Again, this is a bit of a simism. As you can see, the standby does not have a pull for standard, but standard will be set on the altimeter if you pull the knob. So it will set standard across all of them, but in reality you can't pull for standard on the standby, you can just set it in that window because this knob is missing there. Next we have this gauge. Now, this gauge might be familiar to some people, and I was interested when I first saw it because it's almost exactly the same as what is even on the modern Airbus aircraft here. It's the accumulator pressure and the brake pressure indications from the standby or backup system. So you can see, well, what are we looking at first? Let's not go too far ahead. Acupressure, what is that? What does it mean to us? Well, it stands for accumulator pressure. What is an accumulator? It's pretty simple. It's just a giant drum of such, sort of like a big vessel that holds pressure inside of it. When I say giant, they're not that big. I obviously taken a bit of liberties with my scaling here, but it's about the size of a small trash can, sort of, and they hold high pressure inside of them. And you can see here, it's saying I'm in the green and I'm good to go. But why do we have this indication? Well, actually, if you leave the aircraft, and sometimes you'll notice this in the INI A300 when you load in, that the accumulator pressure is not in the green arc, it'll be down here somewhere. And that's because the pressure has slowly leaked out. That trash can sized vessel, it's not perfect, it's got seals and the seals leak, and it's not going to endlessly hold the pressure that you put in there. It just slowly but surely over time leaks the pressure out. And actually it's quite quick on the A300 compared to other Airbus aircraft, so this can be an issue. So if you've parked the aircraft up and not used chocks, it can basically lose so much pressure that the parking brake will lose braking ability and the aircraft will roll away. And that's caused many, many accidents across all airliners in the world because they virtually all work the same way. So that's why part of the check is you want to see that this accumulator pressure is in the green. Now, below this shows the brake PSI that's being applied to, well, you guessed it, the brakes. So at the moment you can see that it tops out at about 3,000, the green arc is 1,000, and that's for a different reason. So I know it looks a bit odd that the arrows are not in the green. You think, well, why are they not in the green? Why are they above the green? This is to do with emergency systems when you're using them, so it's to do with landing without the primary braking system. We'll leave it there. It's a bit complicated, and that's basically the best way to do it. So being above the green is normal. In fact, it should be where it is right now. If they're below that, so if they're in the green, then it's, maybe the brake pressure isn't quite enough, and it might actually roll off on its own. So why are we seeing indications on here right now where we don't normally see it? Well, the parking brake works on this alternate braking system. It's a bit unfair to say that that's not 100% technically correct, but it effectively uses the yellow hydraulic system to do its braking for it, whereas the normal braking system uses the green system. But as we sit here, the green system we saw it's powered down. There's no pressure in it, and it doesn't have an accumulator. So they decided to use the yellow system for the parking brake, and you can see that has an accumulator, and that's what this display is for. So all we need to do in terms of a setup is have a look at it. Does it look normal? If it doesn't look normal, there's a few ways that you can recharge it, but we will come to that when we reach that. It's kind of a cool little A300 ism of sort. I've not seen it on any other Airbus aircraft, and it's actually, I personally think they should be fitted to this feature that we'll come to afterwards. I've got you on the edge of your seat now. You're ready to find out this amazing feature that helps you charge an accumulator. No, I'm just kidding. We'll come to that later. Brake / anti-skid. What does it do? Well, it's the brake / anti-skid system. Clues in the name. It's to do with the braking system. So you see you've got normal. Can't quite read it on this side, but it's alternate. But all we need to know really is it should be in normal. If you put it in alternate, then the primary braking system, do you remember we just said it works on the green, it will swap to working on the yellow. That's basically what it does, and it's used for emergencies only. Unlike the A320 series aircraft, your nose wheel steering will keep working. It's not in the A320 it's called the brake / anti-skid nose wheel steering switch. In this it's the brake and anti-skid steering switch. So no nose wheel steering in that lettering there. There's a little light here that says, I believe it says brake fail, which is to do with when the brakes have failed, and up here I think it's an auto brake light that flashes when they disarm because of a failure. So that's what these two lights do here. Auto brakes, so we have max, mid, low. As you notice, we can't do anything with them right now because we don't have hydraulic pressure. We require to have hydraulic pressure to be able to arm them. You wouldn't want to arm them when the engines are off anyway. Standard setting for takeoff is max. Makes sense because if we do a rejected takeoff, we want to have maximum amount of braking available to us. Now, some cool things to know about the auto brake system in the A300 is works roughly the same way as the A320, but for people who haven't flown it, let's talk about that now. So once it engages, you get a little, it doesn't say decel, it's a little green bar at the bottom, and that will flash, or it will indicate when you are achieving 80% of your braking deceleration rate. Okay, let's break that down to what I mean by that. So each auto brake setting has a target deceleration rate. So it goes, I need to decelerate at this rate. And when it achieves 80% of this, the little green light comes on. Now, cool thing in X-Plane is friction between landing gear and runways is modeled and changes depending on the type of surface that you're on, be it tarmac or wet slightly, kind of modeled it, and dirt. So it doesn't always work because sometimes it will get enough braking action, but if you kind of want to test this feature, if you so wish, it doesn't normally end well, let's put it that way, but it's an interesting one. If you find a long enough dirt runway, or a short one, it doesn't really matter because it's going to be a bit of a crash anyway, and you try and do a rejected takeoff, it feels like the auto brakes don't work at all, and you don't get the green light, and you might think, what the heck, they didn't work. Now, they did work, but because they're on dirt, they can't brake enough to actually achieve 80%, so the light never comes on. They're braking as hard as they can, but it's just skidding, because dirt does not have obviously the same sort of traction as tarmac or concrete. So, quite cool, all modelled in reality, just like the real thing. Another thing to note, this is more of a general thing about auto brakes. I believe it's the same across Boeing and Airbus. If you land with medium auto brakes on, let's make up a number, on a 3,000 meter runway, which I believe it's a more than 10,000 foot runway, so a big runway, and we touch down right at the beginning of the runway, know that doesn't make any sense, but you land on the aiming point. But let's imagine we landed on 0, so it's 0 meters. And then I let the aircraft land, and I had medium selected. And let's say it came to a stop 1,500 meters into the runway, so like halfway down, so 5,000 feet down the runway. Now here's a question for you. Pose it to you so you can answer it in your own head. If I used reverse thrust, would I stop any quicker? Or would I stop later? Or what would it do? Giving you a moment. The answer is another trick question. It has no effect on your braking distance, with some exceptions that we'll talk about. Because it's trying to achieve a deceleration rate, if it can achieve that rate, it just brakes, and that's it. It brakes and it reaches the rate and goes, okay, now I'm going to release the brakes a bit, go and maintain this deceleration rate. No issues. If you use reverse thrust, it will be able to achieve that deceleration rate by using less braking force, because some of the deceleration is coming from the reverse thrust, which is great. So you'll come to that stopping point 1,500 meters into the runway, as we said, without using reverse thrust, but the brakes will be a lot cooler because they haven't had to brake as much. So that's the advantage of using reverse thrust. Now, where does this not really work and where this kind of falls apart? If you're using manual braking and you just stomp on the brakes, I mean like just hit them, push them all the way down, maximum braking, then obviously it's not aiming for a rate. So if you do maximum braking and reverse thrust, you are going to stop quicker than if you didn't use a reverse thrust. I think that makes sense, kind of, you know. And also, Auto Brake's max is such an aggressive deceleration rate, it might not be able to achieve it. That's not true. It should be able to achieve it, in fact, without the reverse thrust, because that's the whole point, in case you have a engine failure as such. So it still should be able to achieve it. One more thing to talk about with the Auto Brakes. You can use max for landing in the A300. I'm going to go as far to say as I don't recommend it. It also does not recommend it in the FCOM or the FCTM, but it does not prohibit it. Unlike more modern Airbus aircraft where you just can't, you select it, it's not a valid landing setting, it won't work. In this it will work, it's just really not recommended because it's incredibly aggressive. It's basically like doing a rejected takeoff, yeah, as such. And older Airbus aircraft, like the older A320s and A330s, you could also use max for landing, but they disabled the feature because too many people going, oh, let's use max, and then passengers are getting thrown in, literally thrown into their seats, and they're overheating the brakes, and they thought, okay, let's just stop this. It's either low or medium, that's your lot, or do it manually. A little bit of an insight to how people fly these. Generally, the Auto Brakes are not used on the A300 because they're quite aggressive and also quite difficult to disengage. So if you press on the brake pedal, it will disengage the Auto Brakes, but you need to press quite fast, so you end up kind of jerking the plane so it just feels uncomfortable. So people generally do manual braking, but they work exactly as they should do, and they're very, 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 very powerful. Just like on any airliner, they're very powerful, but the A300s are carbon brakes as well, just like more modern Airbus aircraft. I believe they were one of the first with carbon brakes. So if you think about your sports car now, it has a carbon brake kit. Like, look at me, I've made it in life. I've got myself a set of carbon brake pads. This thing in 1982 had carbon brakes. So yeah, you can imagine they're not cheap. But anyway, let's move on from the Auto Brakes. Center instruments here, pretty obvious. It's just the engines. We've got left engine, right engine. So N1, EGT, N2, FU. It's a bit rude, isn't it? But FF, FU, and bad joke there. And the pressure indications. So what are these? Well, I'm not going to go over them too much, but N1, the rotation of the big fan on the front. EGT, exhaust gas temperature, how hot is my engine. N2, the fan in the middle of the engine, or the spool in the middle of the engine, how fast am I spinning. FF, fuel flow, how much fuel is going in the engine. FU, fuel used. Now, we're going to talk about this gauge a little bit more because it's also, it's a pretty bad gauge, to be honest. Well, no, it's not fair. It's just a bit quirky. So once you know how it works, it's fine. You often see people saying, oh, I've used too much fuel, or this, that, and the other, it doesn't make sense, but the analog needle, so this needle here, shows your fuel flow, okay? That's where it says FF, kilos, and a nice little trick, if you change it to pounds, this whole gauge cluster here changes to pounds and also changes the scale of the arrow, well, the pointer, so that it matches, and that's can be done at any time. It actually was a lot of work to get that working really well, but we wanted people to have that full experience. So if you change it to pounds or metric, get there eventually. If you change it to imperial units, everything is imperial in the plane. There's no holdovers, everything's in pounds, the gauges are changed to pounds, and if it's in kilos, everything's in kilos. And generally, actually, a lot of operators do use pounds, even in Europe, so just a sort of bit of a side note. But back to why this gauge is a little bit strange. So the needle on the outside shows your fuel flow. So if the needle's on the 2, it's 2,000 kilograms per hour. If it's on the 4, it's 4,000, etc., etc., etc. In the cruise, generally it uses around 2,100, 2,200 kilos per hour per side, which, to be perfectly honest, is a very respectable fuel flow for an aircraft of this age. That's actually pretty good. It's about double what a 320 will do, but it's also double the weight. So that's not bad at all. And the engines that we're using today, the General Electric engines, the Pratt & Whitney engines have an extra gauge at the top here called EPA, which stands for Exhaust Pressure Ratio, which is it's a fancy way of indicating how much N1. Not really true, because you also have an N1 gauge, but it's the same thing. The higher the number, the more power. The lower the number, the less power. Let's just leave it at that. We're going to focus on the General Electric engines because they're kind of more conventional, more what you might be used to. So we will eventually get to why this gauge is strange. So that makes sense. The arrow points to how much fuel flow is happening. This gauge shows you how much fuel has been used. So if it shows 03.0, that's 3,000 pounds of fuel has been used. And it's just so you can keep track on how much fuel is using. It's not a digital indication of what the analog arrow is doing. Why this is a bit of a confusion is all of these other gauges, this is a digital indication of what the analog gauge is doing, but on this one it is a different gauge. That's why it has a different label, the fuel used, FU. Let's not dwell on that anymore. As you know that now, it makes sense. I want to come to a really nice immersion feature that we implemented on the INI A300. You might be able to see it, but maybe not. But I want to point this out because it took the team a long time to get this right. Each individual display here has a slightly different color LCD screen. And what's an LCD screen? Liquid crystal display. So we said we've got CRT, the cathode ray tubes, as we mentioned, the PFD and the ND, and the ECAM screens here. LCD is the sort of more modern technology, but it's smaller, but also they fail. I wouldn't say often, but they fail. I'm sure you've seen it in your car where you have a display and it kind of goes all black and doesn't work anymore, and half of it is like, it looks like it's leaking. That's because the liquid crystal is leaking out, but we're getting too complicated here. So often these are replaced at different times. So you'll see lots of A300 with sort of multicolored displays, so they all look a bit different. At this point we've got the backlight turned off, but if we turn the backlight up, which we will do in a minute, you'll see that each of the displays actually have a different colour to them, and that's realistic, and we've copied it from a few real aircraft that are flying around. Same with the LCD screens on the thrust rating panel. I personally think that's a really nice little feature, nice little trick that we were able to do, and it took a lot longer than you might expect to get that to look authentic. So, let's move on. What's next? We're getting there. I know this is taking a long time again, but it'll be worth it. You'll be an expert in the A300 by the end of this. It's the TRP. Ooh, what is this? Well, if you've flown a 7.5 or a 7.6 or other Boeing products, you're going, oh, I know exactly what that is. That's a thrust rating panel, and it works like this, this, and this. Yes, it works basically as you would think a normal one would work. But if you're like myself and you're used to more modern Airbuses, you just go, what's that? That doesn't make sense. How does that work? Well, it's not that complicated-ish. Okay, so it's not that complicated-ish. Doesn't help, I know, but let's look at it. So, Let's work from the top to the bottom and go through all the different gauges. TAT, well, it's the temperature. So at the moment, it's 14 degrees Celsius. That makes sense because we can see here and here, that is the temperature. Fuel is the same temperature as well because we've been sitting in the sun, or, well, lack thereof sun, because it's 14 degrees. And that's how hot we are. What is this? This is the thrust limit and the limit mode. So this is the maximum N1, so the maximum N1 there, that you will get from the engine using the limit mode. So the mode is TOGA. See that? So it's saying TO for TOGA, take off, whatever. I'm not actually 100% sure what the TO stands for, but the important thing is it's the TOGA mode. So why does this, isn't this a fixed value? No, actually, depending on the temperature and depending on your altitude, it will change. So on a hot day, you'll get more, on a cold day, you'll get less for various complicated engine reasons. Basically, let's leave it at that you get different thrust limits, basically. So you'll see this number is different all over the world because it just changes all the time. MCT, that stands for maximum continuous thrust, so it's a lower limit than the TOGA limit. And let's click on the next one, which is CL. What does that stand for? No guesses? No? It stands for climb. That's crazy, right? It's not crazy, it's pretty obvious. So you can see that the limit mode has changed to climb, and you can see that the limit is a fair bit less than the TOGA, which makes sense, right? This is the thrust that the aeroplane's going to climb all the way to its cruise level at. And it's lower than TOGA because it's less power. Makes sense. But you will see this number, this climb number here, or any of the numbers, change as you climb, because I just said that it's based on temperature and altitude. So as we go higher, it gets colder, so then the limit can go up. So generally, as you go higher, the thrust limit gets higher as well, and the plane will automatically do this. So you don't have to worry about it. It's just, that's why you'll see this number scaling as you climb. And these are all exactly the real world values, which is cool. CR stands for, any guesses? Any guesses? No? Cruise. It's not that complicated, don't worry. And this is the limit for cruise. Again, it makes sense, really. You know, TOGA, maximum continuous thrust, climb, cruise. That's it. But do you care about these? How do I use them? Comes to that in a minute. Let's just finish the panel off. 2 more buttons. Auto. Flex TO. What does this stand for? So let's go to Flex TO first because it's a bit more simple. So if you're used to a modern Airbus aircraft, I don't know how, honestly, I must have said that so many times now, you must be sick of it, but I know I keep going back or forward, whichever way you want to look at it, to modern aircraft, but I'm sure a lot of you are familiar with them. So I don't want to try and, you know, say, oh, this is different. No, this is actually a fairly similar system that you're used to. And also, I think it's a D rate or an assumed temperature, I think they call it on a Boeing, but it's a fairly similar system to that. So from our EFB accurately calculates reduced thrust takeoff. So I'm not going to say what is that because it's pretty obvious. It means you don't use TOGA, basically. So you can already see TOGA is 101.4, and at our flex temperature of 45, it's 99.7. So you don't just press this button and it automatically, you know, puts the number in and it's calculated. It's not that clever. You have to look at the EFB, look across here, and set the number or the temperature, whichever way you want to look at it. So the number, the temperature that it says on the EFB, you set in this window here. If you intend to do a flex takeoff, you don't have to do a flex takeoff, just if you want to. And I would say 99% of real world operators will. Why will they? It's a good question. Less fuel, less noise, less engine wear. It's better for everyone, basically. And as we're going to come to, you definitely don't need toga in this plane. It is ludicrously overpowered. I mean, dangerously so. We're going to come to this when we do a takeoff, but it is not uncommon that if you're light and you use toga, you will see in excess of 7,000 feet per minute after takeoff. That is insane. And you might think, oh, maybe you just modelled it wrong. Trust me, it's not. We have modelled it accurately based on real data, and we have testimonials of the pilots who fly them that say, no, that's right, it climbs like crazy, and it really is insanely overpowered. And it actually kind of makes sense, because the engines that we have fitted here are roughly, I know I keep saying roughly a lot, but they are roughly the same engines that were fitted to the A330. Well, this isn't as big or anywhere near, this isn't as big or is anywhere near as heavy as the A330, so it's going to have an enormous amount more oomph as it goes, and it definitely does. At maximum takeoff weight, this aircraft has a higher thrust to weight ratio, so how much thrust it can produce to the weight that it's got, than nearly any other aircraft on the planet. And honestly, you can tell. At maximum takeoff weight, it is incredibly impressive how it climbs. On par with the 7.5, if not more. And the 7.5 is seen as a rocket, but this thing, I believe at maximum takeoff weight has a higher thrust to weight ratio than even the 757, which is something to behold. I'm going to put it that way. We'll see later on. So, coming back to our original thing of the thrust rate panel. Flex, you set the number that you put in the window. Obviously you wouldn't do it now because you haven't done any calculations, but we're just going to say, alright, we're going to flex and take off and it's going to be 47 degrees. We'll do the calculation later and we'll set it properly, but we're going to leave it like that for now until we press the auto button. Auto. Okay, what does this do? This is going to take a little bit of explaining, but we're going to keep it basic and expand on it later. So, if you do a takeoff where you're letting the aircraft take its information from the auto flight system, if you leave it in auto or flex takeoff, then all of these modes, so climb, cruise, whatever, are all dealt with automatically. So if you leave it in either auto or flex for takeoff, and you use what we call a profile takeoff, then everything is dealt with automatically. If you do not do a profile takeoff, you have to manually select these modes. So you have to manually, at your acceleration, altitude, click climb. When you're at the cruise, you have to click cruise. When you want to use toga, you have to click toga. Okay? Which can be a bit, I don't know, I forget. I forget sometimes. So I generally stick to profile, which is what most people who fly the line also do because it's nice and simple. So if you put it in auto, you can see it's going to take care of it automatically, but it's going to use toga. If you put flex, then it's going to use the flex, this thrust limit here, not this one, but it will automatically swap between the modes that it needs. I know that's quite complicated, but what do you need to know from this? You can set your flex temperature there, that's how you set it, not in the FMS like modern Airbus aircraft. And if you do a profile takeoff, which will be covered later on, you don't have to worry about it, basically. If you want to do more advanced stuff, then you will have to worry about it. But that's the thrust rating panel. Okay, so I think we've come to the end of this sort of FCU middle section here. Obviously on the first officer's side we have a replication of everything that we just talked about, minus a few instruments. One I forgot that was just hiding. I can see it peeking behind the control wheel, not the yoke. See, I got it right that time. I don't want to move the camera just so you can see it here. It's a metric altimeter. So it's just an altimeter, but it shows meters. If you're flying in Russia, for example, they generally use meters, and some parts of Asia. So it's just an altimeter, but in meters. That's it. So that finishes off this section. Let's move